Hello and welcome to Module 5 in our Python series. Today we're going to be discussing dictionaries followed by sets, and then we'll do a second Python project. Before we begin our discussion on dictionaries, we need to look at the two data types. We have sequence data types and mapping data types in Python. In terms of sequence data types, we've already worked with them. So we have lists, tuples, range, and strings. List, strings, and tuples, as we've seen, have many common properties such as indexing and slicing. Right? Strings and tuples are immutable, but lists are mutable, meaning they can be changed in place. Remember that when we have a tuple, so if I have tup equal to 1, 2, 3, and then I have tup1 equal to 4, 5, 6. If I want to join these together, I have to create a new tuple, right? So tup3 equal to tup plus tup1. Right, and then I would have tup3 and I would have that combined, but I cannot modify them in place. Right, moving on. Those strings are immutable. The join method can be used to concatenate different strings. So you will remember that we did something like this. If I have L1 equal to tuples, comma, R, comma, immutable, I can do something like this, space dot join x dot capitalize. Remember we did something like this for x in L1. And then what did we get? We got the strings with the first character in uppercase. But of course you can see that this is a concatenated string. The range sequence type represents an immutable sequence of numbers and is commonly used in for loops. Remember we've used the range in for loops many a time. Tuples and lists are compared lexicographically. Strings use lexicographical ordering as well in Python. Now to give you a visual of how lexicographical ordering works, if you look at these 4 strings, just by scanning with your eyes, you'll figure out that Pascal should come before Perl, Perl should come before PHP, and PHP should come before Python. How did he do that? Because you realize that A comes first in the English alphabet, followed by E, then H, and then Y. Right? Another example, if you have strings like this, when you scan these with your eyes, you figure out that these 3 start in R and A, or the first 2 letters are R and A. Then you have C, but you have B here. So this one comes first, followed by raccoon, then rat. And then you look at reindeer and rhinoceros and figure that reindeer should come before rhinoceros. That's lexicographical ordering. So here are some more examples for lexicographical ordering. 1, 2, 3 is less than 1, 2, 4. Why? These two are the same, but then 3 is less than 4. Similarly, here in this list, here in the strings, A is less than C, right? Therefore, ABC less than C. C is less than P, therefore C less than Pascal. PA less than PY, and therefore Pascal less than Python. Similarly here, 1, 2, 3, 4 less than 1, 2, 4, because we have 3 but we have 4 there. And here as well, 1 and 2, we've got 1 and 2, but we've got nothing to compare with -1, and therefore that's less than. 1, 2, 3 is equal to 1.0, 2.0, 3.0. Okay, so the float of the same number, right, 0.0 that is, not if I say 0.02 or 0.03, 0 is the same as the integer. Then I have 1, 2, double A and B less than 1, 2, A, B, C, A and 4. You figure out why, right? Okay, moving on to the mapping data type. There's only one standard mapping type in Python. It's called a dictionary, also known in some languages as associative arrays. Now, what's an associative array? As is mentioned here, it's an abstract data type composed of a collection of key value pairs. This is important to remember because that's exactly what dictionaries are, key value pairs. Dictionaries are based on the implementation of a hash table. Now you may ask, what is a hash table? And the answer is, a hash table is a data structure that can map keys to values. How? A hash code is computed for each key stored in the dictionary using the built-in Python hash method or hash function. Right? And that hash code will map the keys to the values. Now, just to give you a visual idea of how dictionaries work, these are the keys, right? These are the values. And these that you can see are the hash codes. So, the hash code for the first entry has been computed as 873, and so the value is stored accordingly. Similarly for the second and the third. Right? As you can see, there's no order, it's just arbitrary values computed using the hash method. Now, there could be a situation where the computation of these hash codes leads to two keys having the same code, and that's what is known as collision within the hash table. So here you can see that this key has the hash code 152 and this key as well. The hash algorithm will resolve this situation in one of two ways. One way is, as is shown here, it will chain all the values that have the same hash code. Okay, and the other method is that the hash algorithm will compute a new code and check that it has not been assigned to another key. Okay. To sum up then, with regard to keys in dictionaries, unlike sequences which are indexed by a range of numbers, dictionaries are indexed by keys. They can be of any immutable type. That's very important. Strings and numbers can be keys because they are immutable. Tuples can be used as keys as well, as long as they contain strings, numbers, or tuples. Lists cannot be used because, remember, lists are mutable, meaning they can be modified in place. These are what are used as arguments to the hash function. It's best, therefore, to think of a dictionary as a set of key value pairs with a requirement in Python that the keys are unique within one dictionary. Now we're going to do some work with dictionaries so we understand how to create them, how to insert into a dictionary, right? How to remove from a dictionary, etc. So we go straight to the shell and we start with, so here we have bit 1 equal to, this will be the key and the value. Okay, and another key and the value. So this is our dictionary. Note how they are key value pairs separated by a comma. If you use a type method, Python will tell you it belongs to the class dictionary. Right? I could also create a dictionary using dictionary comprehension. How do we do that? We can say equal to curly brace key value for x in range 10. Okay, I think I used the wrong brackets there. Okay, so that's our dictionary. Type of decomp dictionary again. So that's using dictionary comprehension. You can also create a dictionary. How? By using the type constructor. DICT. Okay, how do we do that? Let's say we have a list of tuples. Louise, comma, that's our ID. Then we have another entry. So another tuple there, comma. So this is our list, right? And then we can say dict equal to dict using the type constructor of list1. And if we look at dict, you see we have the dictionary. Okay, now what happens if we add a duplicate here? Let's say we have Lily again, comma, with a different ID, and then we say, what does that look like? You can see now that Lily has taken the last value. So that's what Python does. Okay, there are duplicates. It will take the last value and assign that to the key. Okay. Also very important to note that we cannot do something like this, which is, and now if we try to create a dictionary from this, right? Let's say, you can see here it says dictionary update sequence element 0 has length 3, 2 is required, and that's by Python's design. Okay, you can create a dictionary out of tuples, but the tuple itself, that's an iterable, right? And each iterable should have only 2 objects. We cannot have 3. Right? Now we can also use the zip method. So let me show you what is a zip method first of all. You can use that on a list. So let's see, I have L1 equal to, okay, and then I have L2 equal to, and then I can say L3 is equal to list of zip of L1 comma L2. Okay, and then if I look at L3, I will have apples 1, oranges 2, grapes 3. I can do it in the opposite direction. How? By saying L3 equal to list zip L2 comma L1, and then L3 will have 1 apples, 2 oranges, 3 grapes. Note one thing, if I just say L4 equal to zip of L2 comma L1, it will just show me the zip object at this place in memory, right? I cannot see the contents. I need to use list. Now I can use the zip method to create a dictionary. I'm going to just clear the screen now. Let's take our list 1, right? Actually, no, let's separate this. So let's have list 1 equal to, and then we have list 2 equal to, and then we can say new dict equal to dict of zip of list 1 comma list 2. Okay, now we look at new dict. You can see we have the dictionary. Now let's see how to insert a new key value pair. How do we do that? We can say new dict Marilyn equal to, and give us some number. Okay, and then if we look at new dict, you can see that the new entry has been added in, right? Now moving on, what happens if the number of elements in one list is greater when we're using the zip method? So let's say we have list 1, right? And then we have list 2. And let's put in another number here. Okay. And what happens now if we say zipped equal to dict of zip of list 1 comma list 2. We look at zipped, you will see that this has been ignored, right? Because we don't have a key. Okay. Now how do you get dictionary keys? That's the next thing. Get access to dict keys. One way to do that is to say, let's use zipped for that. If I can say zipped dot keys, we use the keys method, and you can see you have here dict keys and all the keys. But of course, if you want to avoid getting it, with this dict keys method, what you can do is you can say list of zipped. Okay, and then you get the keys. Right? Similarly, if you want only the values, you could say zipped dot values. Then you get it in this format, right? So you could say list of zipped dot values, right? And then you could work with that list. Now you could create a copy of a dictionary by using the copy method. By the way, you could also use it on a list. If I have list 1, I could say list copy equal to list 1 dot copy. Okay, and I have a copy of the list. Similarly, you could use the same thing with the dictionary. So I could say dict copy equal to zipped dot copy. And then you would have the copy of the dictionary. You could also delete a dictionary, right? So now we've got zipped, right? And we've got dict copy as well, which are the same. So we could say del, right? Dict copy. Okay. And now if you look at dict copy, it's no longer existent, right? Now I'm going to create a copy again, right? And then watch what happens if I clear this dictionary. So if I say dict copy dot clear, now if I look at dict copy, it's still there, but it's an empty dictionary. Let's look at the original one, zipped, and we still have it. So this is how you could use clear. You could use delete. With delete, the dictionary is gone, right? But with clear, the dictionary is still there, it's just empty. Okay, now how to use update? Let me just scroll down a bit so you can see. So now we have, let's create that copy again. So we have now zipped. Let's say we create another dictionary. New employees equal to, and now we need to update the original. So we need to update zipped. You can use the update method. But what if we cannot use the update method? Then what we do is we do something like this. For key, comma, val in new emp dot items. And here is where you get introduced to the items method, which allows you to access each and every key value pair in the dictionary, right? And then we can just say zipped of key equal to value. Should have said val. Let's just do that again. For key in this, zipped of key equal to val, right? And now we look at zipped. You see that the new employees have been added on. Now, like I said earlier, you can use the update method. We have dict copy, right? And we could say second copy equal to dict copy dot copy. Okay, so now let's update dict copy. So dict copy dot update, and we can say here new emp. Okay, and then we look at dict copy, you can see that that's been updated. So that's using the update method. You could also use what is called the unpacking operator. So for that you would say, and let me create a third copy. Okay, and we'll update the second copy using the unpacking operator. So for this, what we do is we just say updated equal to star star, that's the unpacking operator. We've got sec copy, comma, star star, new emp. Oops, mistaken the brace. And now if you look at updated, you can see that it has the updated dictionary, right? There's yet another method, okay? So here we could see, let's just call it merged equal to sec copy merge, that's the operator, new n. Okay, and then if you look at merged, you would have the merged dictionary. Now you could also merge in place. We could say sec copy merge equal to new n. So now if you look at sec copy, it has lost its original key value pairs. It's got the updated one. Okay. Okay, now I'm going to create a new dictionary. Let me just clear the screen. So we're going to call this national birds. And this is another way of creating the dictionary. We're using the type constructor, as you can see. USA equal to bald eagle, comma. Right, so if you look at national birds, there you have the dictionary. Right? Now what if we want to update this dictionary? Let's say we have a tuple equal to, and then we can convert that to a dictionary. How? We can just say new bird equal to dict of tup. Right? Oops. We've got to specify it as a list of tuples, okay? So new bird equal to dict of tup, that's the syntax. Now that we have this new bird dictionary, we can update it. So we can use the merge, for example, national birds merge equal to new bird. And if you look at national birds now, okay, spelling mistake there. Right, you have the updated dictionary. Now, nested dictionaries. I hope you're following everything so far. If there's any questions, please don't hesitate to post in the comments. I'll get back to you as soon as I can. So let's say we have a dictionary pets equal to my pets. Okay, so this is the key. Now the value within a nesting. So here we have another key. Let's say pet 1. Then we have another dictionary name. There's a key. New key, comma, we have another key about, and then we have another dictionary with another key breed, right? And then we have color, which is another key. Its value is white, comma, we have loves. What Yuki loves to do is playing with treats. Okay, and now we have 1, 2, 3, 4 opening curly braces, so we've got to close all those. And this is my dictionary. Now let's say I have another dictionary equal to, So now we have these two dictionaries. We want to update the first one. How do we do that? We just say pets dot update. I'm using the update method here. New pet. And now if you look at pets, we'll have both entries. Now what if I want to access what UP loves? That is this value. Then I would say print. Now I would mention the dictionary name. And now I've got to go through the nesting. So my pets. That's that key there. Which other key do I need? I need pet 1. Right? And then I need about. I don't need name. I need about, because within about I will find loves. Right? So about. And then I can access loves. Close a print bracket there. Okay, there's some invalid syntax here, which is a quote. Okay, and there you have the value of the loves key. Okay, the last thing we need to discuss about dictionaries is how we initialize them. Default info, let's say I have something like this, equal to, and then I have the interns equal to, right? And now I want to consolidate this. So what do? Meaning, what I want to do is I want to initialize the dictionary with each of these interns having the same designation and salary. How do I do that? I can just say consolidated equal to date. Now I'm going to use the from keys method. And then when you look at consolidated, you have each of them with the designation and salary. Right? If I wanted to get a particular person's details, I could say consolidated dot get Alex. There you have the designation and salary. Right? If you wanted to get only the salary, you could say print consolidated semi and then specify the salary. Okay, and you get 5,000. Now looping through dictionaries is easy. We just use the key value pairs. So let's take, for example, national birds, right? And we could say here for K, V in national birds dot items print K, V. Okay, and then you would get the countries and their national birds. How would you do this in, let's say, a sequence data type? You would use the enumerate. You remember that? For I, V in enumerate print I, V. Okay, there's a mistake somewhere here. Enumerated is not the function, it is just enumerate. Print I, comma, V. And there you have it. Now you can see here there's 0, 1, 2. You know what to do, right? All you need to do is to say here, comma, start equal to 1. Right? And then print I, comma, V. Right? And there you have it. Moving on. A set is an unordered collection with no duplicate elements. Remember, sequence types are ordered. What do I mean? So, each of the elements in the list are accessed from the 0 to first, second, third position, etc. So, that's the order. Dictionaries and sets are unordered, right? This, both dictionaries and sets use hash values. Okay. Set objects also support mathematical operations like union, intersection, difference, and symmetric difference. Okay, so you've learned about sets in mathematics, I'm sure, in school, where you have A union B, A intersection B, etc. It's the same concept. Basic uses include membership testing and eliminating duplicate entries. Curly braces or set. The method can be used to create sets. To create an empty set, you need to use set and not curly braces, as this will create an empty dictionary. Okay, so now let's go to work with sets a bit. Let's say we have muffins equal to, and this is a set now that I'm creating. Note that there's no key value there. Now I can use a simple membership operator. So I can say chocolate in muffins, true. Strawberry in muffins, false. Also, let's show you the demo of different set operations. So for example, I can say A equal to set of bananas. Say B equal to, right? Now watch, if I say just A, it will give me the unique letters in E. You see, without taking the duplicate. Similarly, if I say B, it will show me the unique letters in B. So, next, let's say we wanted to know what is in A only. Right, so I would say A minus B. You see, that's only B there. Right? So now what if I wanted to see letters in A or B or both? Then I would say A or B. So those are, what if I wanted to see letters in both A and B? I would say A and B. This shows, okay, that was a mistake on my part. A and B, right? So that shows letters in both A and B. And then you can have the symmetric difference, which is A or B. Right? So this shows what? Letters in A or B, but not both. So I'll make a note here for you. Now we also have set comprehension, just as we had list and bit comprehension. We could say A equal to X for X in abracadabra if X not in ABC. Okay. Then if we looked at A, you would see the letters that are not in ABC. Okay, so that finishes our discussion on sets. Now for our project. Okay, so we need to go to idle. Now the project we're doing today is Tic-Tac-Toe, which is, the what you would call X and O's, right? So that's what we're going to do. We need certain functions here. So here we have the main function. We need to draw that grid. We need to also show the grid, right? So that'll be a separate function. Basically display that grid. Then we need to check the grid to see whether all spaces have been filled or not. We need a function to check if there's a winner and who the winner is, X or O. We need a function for computer play, user play, and we have this little function that will be called from both of these. So let's get started. We are going to start with this main function. As I said last time, this task is so that if you have functions where you've not put in the code, right, the functions where you have code will still run. So now let's see, I have here global grid. Okay. Why do I have global grid? Because I'm going to be accessing this variable from other functions as well. Then I have grid equal to, now an important point. Remember, we got to declare this as global first and then initialize it. We cannot initialize it and then declare it, right? Because then we're using or assigning a value before declaring the variable. And then we have global of flag and global of winner. Now what's the first thing we need to do within this? We need to draw the grid, and that is initialize it. So we'll call the draw grid method, and within the draw grid method what we'll do is, here, because we're going to be changing the value of grid, we've got to mention global grid again. Okay, and then say grid equal to, this is going to be a two-dimensional array. Remember what we did last time? We use list comprehension, 0 for y in range 3. It's going to be a 3 by 3, right? Or x in range 3, right? So that will initialize the grid. Right, once that is done, what's the next thing we need to do? We need to have a loop, right? Because this play will go on until there's a winner. So after draw grid, we can have a loop while true. I hope you know how this game works. Now while true, we say flag equal to space. Why are we initializing that? Because every time this loop goes through, that flag should be initialized. Why should it be initialized? We'll see as we go down the code. We also have winner equal to null. And now we have the user's turn. Okay, you call which function? User play. Right? After the user plays, we've got to show the grid again. So we'll call show grid. And of course, we've got to write show grid. So let's go and write show grid first. What do we write in show grid? Remember, you're just going to be printing it out on screen. Here we have show grid. Let's remove that pass statement. And here we say for x in range len of grid. Right? And then for y in range len of grid. Right? Print grid x y. Remember, we need two subscripts. It's double dimensional array for list end equal to space, so that we have a space after the element. And remember, we leave a blank print so that we move to the next line. So that's our show grid completed. Right, so now let's write the user play method. We need to remove the statement. We need to show the grid to the user. And then we need to now have a loop. Why? Because if the user points to a place, right, which is already filled, then we have to tell the user that that position is taken. We need to try again, right? You have a kind of a variable here, found equal to n, and then we say while found is equal to n. Then we can say your turn equal to input. We need to have a variable here. Why? Because remember, what is going to come in is going to be a string type, right? So what we do is we have a variable row equal to int of your turn of 0, right? And then column equal to int your turn of 1, right? It's going to enter two values. Then what do we do? Now, if grid of row, right, call equal to 0, then what we can say is grid of row call equal to x, right? Else we'll indicate to the user that the position is taken. So this will continue, but remember, we have here found equal to n, so somewhere we have to change it to y, right? So where do we do that? We can do it here, right? After this or before this, we can just say here found equal to y, right? So what will happen? How will this loop run? While found is equal to n, right? This will print a message on the screen. The user will enter something, of course. We will convert that to an integer, and then we will check whether the positions indicated by row and call in the grid have a 0, right? If it does, then found equal to y, and we'll put the x that the user wants placed in that position, right? Else print the position taken, try again. Now once this while loop breaks out, that is when found is equal to y, then what we will do is we will go and execute check steps. We call that function. Now what is check steps doing? Check steps is going to check the grid. So we've got to write that function and also check for a winner. Right, so I hope this is clear. Now let's go and write check grid. What do we write in check grid? We need to see if there are spaces still available. Right, so here we'll say for x in range len of grid if 0 in grid of x, right, because x will represent the row, remember, so there is 0 in that row, we're going to say flag equal to y, right, because we're changing the value of flag, we got to declare it as global here again, right, and if flag is equal to y, then we need to break out of this for loop. Okay, else we'll say flag equal to n, and then of course we have our return statement from this function. Right, so check grid is done. What else do we need to write? Winner check. Now in winner check, remember we are looking for the winner. So let's write that. For r in range 0, len of grid. Okay, so here we are checking horizontally first. So let's put a comment here. Within this for loop, what do? We can count how many x's are there, right? So counter equal to grid r dot count. We're using the Python count method x, and then we count how many O's there are. So com ctr equal to if counter is equal to 3, then what do? We print congratulations, winner equal to x. Now because we are accessing winner and changing the value, here we have to say global winner, and then after the winner is determined, we need to return, right? We need to get out of this. Else or elif comp ctr is equal to 3. Then what do? We print, right? That's the computer. Winner equal to O, return. So I hope you got that. So this is checking horizontally. Now we need to check vertically. We put in a new comment here. For checking vertically, we are going to use a method whereby we can turn the columns into rows. Okay, so that we can check. How do we do that? We just say transposed equal to row of I for row in grid. Okay, for I in range len of grid. So again, we're using this comprehension, but we are transposing the columns into rows. Then we say for R in range 0, len of grid counter equal to, we're using the transposed. Okay, let me show you how this transposed works first. So let's say I have a list equal to, right? Now what I'm going to do is I'm going to assign certain values so you will see. Okay. Right, so now if I just look at 2dim, just without printing anything, you can see that I have these rows and columns, right? Now let's transpose it. Okay, so I'll say transpose, and that's just a variable name, by the way, equal to row, okay, of I for row in 2dim, right? And then for I in range len of 2dim. Okay. And then what happens? I close this, of course. And now if I look at transposed, you see I have 400, 600, and 800. See how it's converted the columns to rows, right? Okay, so that's the similar concept that they're using here. Then what we are saying is counter equal to, okay, and then comp underscore ctr equal to if counter equal to 3, what do? Print winner equal to x, return elif comp ctr equal to 3, print winner equal to O, right, return. So that finishes the checking vertically. Now I'm going to check diagonal. What we'll do is we'll simply say if grid of 0, 0 equal to x and grid of 1, 1 equal to x and grid of 2, 2 equal to x, right? Then we can just print congratulations you won. So you just copy that. Else if, and then you can copy this if you want. So typing it in and just change that to O. So Control C, Control V, if grid of 0, 0 equal to O and this equal to O and this equal to O, then print I1 and winner equal to O. Now that's one way, right? Because you could have, if you look at it, it's starting from the left, then going to the next row, the middle one, and then the last one. Right, so we're checking that. Now we got to check from the right. So elif grid of 0 to, right, equal to x and grid of 1 1 equal to x and grid of 2 0, right? So this is starting at the rightmost column in the first row, then of course the middle row, and then the leftmost column in the bottom row, right, is equal to x. Then of course we print the same thing, so you can just copy that down. Otherwise we got to check if that's equal to O, right? So elif, now again you can take this entire thing, Control C, and copy that down and change this to O. Right, and change this to I1 or I1. We now equal to O. And then return. So now we've checked horizontally, we've checked vertically, we've checked diagonally, right? Otherwise, there's no winner yet, at least. Winner equal to none, right? And return. Now, is this positioning correct? That's what we have to see. So this should come in line with this 4, right? Not within the 4. So let's just move that a bit. I hope you understand why that's not within that 4. So control and open box bracket will bring that to the left. Right, so this is within the 4. Then of course we're checking diagonally. And then of course if we have no winner, and again should come there. So now this is all in line with this indentation, right, the topmost, with the 4 loops being indented, right? So that finishes our winner check. What's the next function we need to write? Computer play. We've got to write a bit of this top function as well. So maybe we complete that top function first. After the user plays, right, we need the computer to play. Once the computer plays, if winner, because remember we are doing the check, then the user plays, we're calling check steps, right? So we are checking if there's a winner here. If winner is equal to none and flag is equal to y, flag, remember, is checking if there are still spaces left, empty spaces that is, then so continue, let us go back into this loop, right? Now if there is a winner, then we should come out of that while loop, right? And we check reply equal to input And then we have to check that reply, of course. If reply dot lower, just in case the user puts in an uppercase, equal to n, right, then we have to quit. So what I'm doing here is I'm going to be importing the sys module. So here we will have import sys, right, and here we will say sys dot exit. Okay, else draw grid again, right, because we got to reinitialize a grid if the user wants to play, and then we go back in the loop. So that's done. Now it's computer play. For the computer, remember we are programming it, right? So let's start with global grid, and then we'll have a variable called my turn equal to n. We will first check horizontally. So here we have for r in range len of grid. Now what we do is we first count how many x's are there, right, and how many zeros are there. So x counter equal to grid of r dot count the number of x's, right, and then 0 counter equal to grid of r, remember that's the row, right, dot count zeros, and then we check if x counter is equal to 2. There are already 2 x's, and 0 counter is greater than 0. That will mean there is place to put our O there. We'll find out the index, right? Index equal to grid of r dot index. So we are finding out the index of 0 in that row. And then all we need to do is say grid of r, use a subscript there, and then use int as another subscript, equal to O. Then make my turn equal to y. That means the computer has finished its turn, and get out of this for loop, right? And here there's a mistake. There should be a bracket, right? Else what do we do? Continue, right? Now when we come out of this for loop, we check if my turn is equal to y, which means the computer has found a place on the grid, or rather not equal to y, I should say. It's not found a place on the grid. So here we now do transposing again. So we start with r equal to 0. Then we say transposed equal to row I for row in grid, right? And then for I in range len of grid. Then we say for our in range len of, do I use grid or transposed? I have to use transposed now, right? Transposed, right? Because those are now my rows. My columns have become rows. And again, I repeat, I count, right? So X counter, and of course 0 counter as well. 0 counter equal to, then we check if X counter is equal to 2 and 0 counter is greater than 0, then we say index equal to transposed of R dot index of 0, right? And then of course we place our O. So transposed of R and then int equal to O. Remember, that is on the basis of transpose that we place our O. But we need to now restore the grid, right? Because now our rows, our columns have become rows. So we've got to restore it. So what we'll do is we transpose it back, right? So we'll say here grid equal to row of I for row in transposed, right? And then for I in range len of transposed. So we are doing the opposite of what we did here. And then of course we say my turn equal to Y and break, right? Else continue, right? So go to the next row in the transposed grid, right? Now when we come out of this, if my turn is still not equal to Y, so if my turn not equal to Y, then what do? We will check diagonally, right? Now how do we check diagonally? We say if grid of 0, 0, right, equal to X and grid of 1, 1 equal to X and grid of 2, 2 equal to 0, then grid of 2, 2 equal to O, my turn equal to Y. Break elif grid of 0, 2. The top row, the last column equal to X and grid of 1, 1 equal to X and grid of 2, 0 equal to 0, then grid of 2, 0 equal to 4. Right? My turn equal to y and break. If my turn is still not equal to y after this, we say for r in range len of grid, we have to check. So here we'll say x counter equal to grid, right? And then 0 counter equal to, so if x counter is greater than 0 and 0 counter is greater than 0, index equal to grid of r dot index of 0, right? We're finding the index of 0, that is, and then grid of r comma, oh sorry, another subscript is int equal to o, right? And then my turn equal to y and break, right? Elif x underscore counter is equal to 0, that means there are no x's in that row, and 0 counter is greater than 0, then again we can put an O over there, right? So we just copy this. Then at the end of this, we need to do the check steps, right? So come out of these. Here we will say check steps and then return. Okay, so that's the computer's play. I hope you got the logic that we're using here. If you have your own logic, that's great, right? If you figure out a shorter way of doing this, that's even better. Okay, so let's see all our functions now. So we start with the first function, right? We have our global flag and global winner. We are importing sys, and then we draw the grid. And then while true, right? And of course we have the user turn, we're calling user play. Then we show the grid to the user after they've played. Then computer play, right? And then we check if winner is none and flag is y. That means there's no winner yet. We continue. Flag is y, remember, is to show that there are still spaces on the grid, right? That can be filled in. Otherwise, then we have the reply equal to, if reply is equal to n, we exit. Otherwise, we draw grid and we continue, right? So now let's run this and see what happens. Run. We need to save this. Save it. And now we have invalid syntax, right? So here, there should be a bracket, no? Right? And again, here there's no bracket, right? So this should complete that. And then we should be fine, right? Continuing, run again. break outside loop. So here we're not within a for loop. So that's an error. And here of course we need them because that's within a for loop. So run again. Let's call our main function. So there you can see the grid printed out. Enter the column. Let's say 0, 0. Now we want to say it's my turn. So let's stop this. There needs to be a message saying it's my turn. So otherwise that looks funny when we have the grid appearing again with no message. Right? So here we'll say after this line, if winner equal to none. Okay, so we see here if winner equal to none or winner equal to null and flag equal to y or flag equal to null. Okay, then we'll say print. So I hope you understood why we're doing this. So this message will appear only if there is no winner yet and there are spaces on the board or the very first time, right, before the grid is checked and before the winners are checked, right? So let's run this now. So it should be a double equal to that one. Right. So now 0, 0 and it says it's my turn. You can see that the O has been put there. So now it's the user's turn, right? Let's say 1, 0 and you can see the computer has placed the O there blocking the X, right? So now let's say 1, 1, right? And now you can see the O has been put here blocking this, right? But this one's open. So now we can say 2, 2 and congratulations, you won, right? But it's still saying it's your turn, enter row and column. So we need to end there, right? And so we'll stop this. So here our message, which is reply, is not appearing, right? So what do? Let's do one thing. Move this inside. Run. Let's say 1, 1, 0, 1, 1, 0, 0, 2, and then 2, 0. And because that's the only space left. Okay, it just says position taken. So let's say 2, 2. Type Y for yes and N for no. If we say yes, then it will initialize and we start again. Now you can play again. Let's say 1, 1. And the computer has played, so it's time for us to play, for the user to play. So let's say 2, 0. Right? Now we can win. The user can win. That is, you say 02. Just congratulations, you won. Okay, so this is how this works. Again, like I said, if you have shorter logic, then that's great. Test this out again. You may still find bugs in it. If you do, please let me know. Right? So that's all for today. In the next session, we will basically work more with dictionaries and sets, right? But we'll also introduce the concept of lambdas and a very important concept called recursion, right? So till then, take care, stay safe. Bye.